So, who am I first? I've been on the Kubernetes team for 2 years. That's as long as we've had a Kubernetes team. I was one of the 2 guys who started it. 4.5, almost 5 years at Atlassian, and yes, it's terrifying that I have been a sysadmin for almost 20 years. Well, actually 20 years this year. So, yeah.
Why is you coming over?
Pardon?
Sorry.
So yeah, before I worked on the Kubernetes team, I worked on On-Demand, which was our in-data centers software as a service version of Jira, Confluence, and Bamboo, and a whole bunch of other stuff. Yeah, we used to do 150,000 VMs worth, customers worth of Jira and Confluence VMs. So that was somewhere in the region of 300 to 350,000 JVMs running across 6 data centers in 3 regions. We don't run data centers anymore. At one point, Mike and Scott were like, we're not a data center company, why are we running data centers when there's perfectly good clouds? So we were, we looked at moving to Amazon. This big project you probably saw something about called Vertigo, to actually move Jira and Confluence to a sort of more microservice architecture, completely divorced from what we're doing. We're hoping that that will happen, that will come onto our platform down the road. Why do we pick Kubernetes? It was pretty exciting, and when we looked at it, the way that they wanted to schedule things across a group of things actually was really similar to what we did on On-Demand. The way we did On-Demand was we actually used really early version of containerization. It was, I can't remember the name now, it's been too long. But it was really a basic version of containers where you basically, the root file system was read-only. That was the other really important thing, was kind of a pre-Docker idea of having a very basic OS that you couldn't change.
That based on the Borg, right?
Pardon?
Wasn't that the Borg?
No, that was a Google. Yeah, no, but we had our own thing that was similar in some ways to that, basically an approximation of what ended up.
Was it Mesos?
No, not Mesos. It was completely custom
It
written.
was based on identity, and that's it. So like the
Yeah.
old way before Docker.
And it was pre-Docker, pre-everything. So this was our guiding star. This is what we were trying to build. We wanted to build clusters that could run 95% of the workload at Atlassian. That means that we needed to be able to do batch workloads, service-based workloads, plus any other thing that the thousands of software developers we had could come up with. So, we needed to build the thing to be as extensible and future-proof as we could from day one. And so, why did we build our own? This is sort of the key part of the talk. When we started 2.5 years ago, the tools weren't ready. The stand me up a cluster tooling was really only good for, this is my first Kubernetes cluster. Woo, look at me, I've got a Kubernetes cluster. From day one, we were like, we want this thing to be bulletproof, to be deployed by CI. We want infrastructure as code. We want, cattle not pets. We want everything as up to date as we could make it. We had an opportunity to build a completely greenfields environment. We had months, like 12 months, before we actually needed to have any customers running, which you pretty much never get. So we were like, we're going to use this thing to build something that we're going to be proud of in years. The other thing was compliance. We started this just after we became a public company. We knew that SOC 2, PCI probably down the road, all of the compliances were coming our way. We wanted to make sure from day one that the compliance regime that we built this to be compatible with the compliance regime we would have to end up using down the road. Atlassian actually has a pretty amazing compliance regime. It's a whole other thing. I'd love to talk to people about it in depth later, but we got lucky on that front as well. And the last one is we wanted to make sure we really understood how to run it. If you are running Kubernetes, I strongly recommend that at some point you take a few days and sit down and do Kelsey's Kubernetes the hard way tutorial that'll teach you how to stand the whole thing up from go to woe. For reasons I'll get into later, you shouldn't do that for reals in prod, but if you need to understand how the system works, Kelsey's tutorial is the best way to do it. Yeah. So, design stuff. Here is my rule 0, designing scalable stuff. Figure out the biggest problems you know you're going to have and make sure you don't have them. Seems simple, right? But yeah, and then you can find all the new and interesting ones that those design choices you've made give you later. And we found plenty, but they were not the problems that we knew about at the start. It was all the unknown unknowns that screwed us down the road, not the ones that we knew about. So, what was the ones we knew about? Well, from running, huge data center things, we wanted to make sure that we managed the blast radius, that there was really strong separation between bits of the system so that you could deploy separate bits of your infrastructure without blocking anybody who was trying to deploy other bits. And so we built a layer cake model based on all the great experience we've had over the years with things like OSI, network layer model and that sort of stuff. It's a really easy way, when things rely on other things, it's a really easy way to make a clear model that will keep you safe from cross-layer things. Next, cattle not pets. Immutable infrastructure is the way to go. If you are running infrastructure these days and you are not running immutable infrastructure, you are in for a bad time. The more that you can get your infrastructure to be closer to immutable, the happier you will be as a person who cares about infrastructure. I promise you. I'll tell you more about exactly where that's got to for us, but you want to be able to be like, wow, that server's a bit weird. What the hell's up with that? I'm going to spend 10 minutes. I don't know. Who cares? It's gone. Done. System self-healed, everything's solved. You don't want to be spending hours and hours and days trying to recover some special snowflake. The last one, managed dependencies. We knew, because we're aiming to run 95% of Atlassian's compute, that eventually pretty much everything will depend on us. So we needed to be really careful that we weren't depending on anything that would eventually depend on us. When you think about your graph of dependencies, it has to be a directed acyclic graph. You do not want cycles in your dependency graph. That is a really bad time, because if everything ever goes down and you've got dependency cycles, when you try to bring everything back up, how are you going to solve those, right? Like, that is a really hard problem. Much better to just design your way around it. Make sure that you don't have them. So, here's our layer cake. Now, before I start on this, there's a little bit of explanation about the naming. So you can see from here, our team is called the Kubernetes Infrastructure Technology Team. Completely redundant T. It's literally only there so that we could use Knight Rider months for everything. Backronyms are great. So, first layer is the flag. In Knight Rider, that's the foundation for law and government who pays for the whole shebang. So this is the base AWS configuration. It will stand you up a new VPC, the subnets in the VPC, the VGWs that connect it to our WAN, most of the security groups that we use. Not all, because sometimes you end up with funny circular dependencies with security groups if you're not careful. But basically this is like all the base stuff. Once we have built one of these, we generally will not burn it down, because burning this down is really hard to put it back, because the VGWs require manual intervention from the network engineers, is the main reason. On top of that, we have the car. Thank you. I know see people have watched Knight Rider. So this is all the compute, the control plane, the etcds, the ASGs that hold the actual nodes, all of the stuff that gets you up to having an API server. Now this API server is completely vanilla. There is no RBAC, nothing. You cannot even kubectl get node, it will say nothing found, because there is no RBAC at this point. But by having this really clear demarcation line, it means that if we have a change to make in our Kubernetes config, unless it is a change to the API server or the controller manager, we do not touch this layer. So as we have got the platform more stable, the number of changes we have made to these two layers has absolutely dropped off really quickly. And so that doing car rollouts is now unusual. We'll do one every 2 weeks, not multiple times per day. The top layer is Goliath. This was the truck that the actual car rides in. But this is all the config that runs inside Kubernetes. So most importantly, it includes RBAC, pod security policies, all of the other stuff that gets poured into an API server to make it a kit API server. So this, the most important part here is that the first thing that goes in is the RBAC, because we turned on RBAC as soon as it went alpha in Kubernetes, and we have never looked back. If you are running Kubernetes without RBAC, you are in for a bad time. That is the equivalent of running a whole fleet of machines where people only ever sign into it as root. It's a terrible idea. Don't do it. Have RBAC. Pardon?
Ask Tesla.
Yeah, exactly. Tesla was a great example of that. The other comment of that you can learn from Tesla: turn off the default dashboard and don't use it. That requires cluster admin access to do all the stuff it does. If you make it accessible, whoever gets onto it gets cluster admin access. So, cattle not pets. So the controllers and nodes, they're created in ASGs. The controllers are in an ASG as well, with an ELB in front of them for the actual API server part. They are all, that ASG is also created with the rolling update when you update the launch config. So to deploy a change to the controllers, we poke a change using Terraform. Where are you, Ned? Both of the bottom layers, sorry, use Terraform. So we poke a change to the launch config for the ASG, and AWS will cycle the controllers for us. The nodes that run workloads, though, we let those get handled by either the autoscaler or manually by us. We've ended up with lots of different node groups for different use cases. In our shared clusters, which is where sort of most of the base workload loads runs, that's where we run our own autoscaler escalator that was mentioned earlier. That one is for batch jobs only. It doesn't work for service-based workloads for a variety of reasons that I can talk to you about later, if you care. But yeah, so in terms of immutable infrastructure, the etc.d servers are a bit special. I put here, they're like milk cows that you know the name of. If they get sick, you're going to go and you're going to spend a little bit more time with them, see if you can get them better, but if not, you're going to be like, I'm really sorry to lose you, off you go. You know, but you stand up a new one and it's all good. But you are a bit more careful with the etc.d servers because if you lose, we run 3, if you lose 2, it's a bad time. It's really hard to build your etcd cluster back up to quorum from only one node. It's really fiddly. I had to do it in an outage yesterday, in fact, and I still fucking hate it. Don't do it. So this is one of the things that's really hard about running your own Kubernetes infrastructure. The end result of all of this is that we can burn the entire cluster down to the flag level, both the Goliath and the car. We can trash the whole lot and build a new one in 30 minutes. Again, this is sort of trying to take the immutable infrastructure thing up another layer and be like, clusters themselves are almost immutable infrastructure in that if anything goes wrong too much, you don't spend too much time trying to retrieve it, you just burn the whole thing down and build a new one. That's going to be less the case as we bring service workloads on because they start actually persisting state inside the cluster. This is only possible right now because all the workloads we have a very strong rule that you push the state out of the cluster. Use the state persistence that's given by your cloud provider. In Amazon, you use RDS or Dynamo or Memcache or the Elasticache or whatever your equivalent of those primitives are. Don't try and keep your state inside the cluster because it lets you treat the cluster as much more immutable. Managing dependencies. The secrets that I'm talking about here are not Kubernetes secrets. These are the secrets that bring the nodes up and join them to the Kubernetes cluster. We saw those inside private S3 buckets that are only accessible via roles that the nodes can assume. This has actually worked pretty well for us. The problem there though is we've ended up with, it's a bit baroque, the actual process because we've now got to a stage where our security requirements have said we've had to turn on node authorization and a whole bunch of other security stuff in Kube. Node authorization requires that every node has a distinct identity, which means a distinct cert, which means that you need to have an automated way that when a node comes up, it needs to be able to ask. It asks the APIs, it asks Kubernetes itself for a cert, for its identity cert. It gets its identity cert, and then from that point it uses it. That's actually built into Kubernetes now. We didn't have to build anything to do that, but the sort of understanding how that workflow works and getting it working is a little bit tricky. And again, and the other one was ECR. We didn't want to be dependent for our stuff to come up on Docker Hub, Key, some internal registry or any other registry. The reason we picked ECR is if ECR is down, the region we are in is down. We are not standing up any new nodes because it's down. At the point when this is not reachable, we don't give a shit about starting new nodes anymore. So again, this is where thinking about your dependencies is really important. We made the call that because we depend on Amazon for everything, that there's a limited amount to which we should care about Amazon being down. You have to assume that your cloud provider is going to meet their SLAs at least, if not better. But the thing is, Key and Docker Hub, you don't have any SLA with them, right? If Key goes down and you're dependent on Key to start your nodes, and you need to scale, guess what? You ain't scaling something. So yeah, this is one of my key things that I tell people. think about your dependencies. If you decide not to do this, that's cool. Do what you got to do, man. You do you. But the important part is that you've thought about how your dependency chain works and you've made informed decisions. So, how did this all go? It's been 2 years. We had a good chance to put a whole bunch of load on there. It's done pretty well. Cluster scale. Biggest size was yesterday. 300 M5 12XLs. That is 14,400 vCPUs and 57 terabytes of RAM. And Jeff got a new yacht from us yesterday. Yeah, like, he actually didn't, because one of the things we do with our autoscaler is that those only run for like half an hour. You know, so we're not leaving them running for a long period of time. I don't want to preempt the discussion of escalator, but one of the reasons we built it was that the default autoscaler is very conservative. The node autoscaler is very conservative in scaling down. If we scale up to like a couple of hundred big instances to run all the build load that we needed to run, it would often take 14 hours or so to scale them back down, even when there was no load running in the cluster.
Was that the entire world moving their GitHub to Bitbucket?
No, it actually wasn't. This is reasonably normal build workload for us. Yeah, it's mainly batch workloads for now. We have an internal HAS team that's building some stuff on top of Cube to do some of the stuff that Jason and other people talked about with making life easier for your devs. The end result of what they are building is that there will be a very limited service descriptor for an app inside Atlassian that you say, I want to run this Docker image, I want it visible to the rest of the company on this name, it needs a database, and it needs a queue. And then this thing will go and busily work away and make sure all those bits are created, wired up, that you get all the auth you need, that the roles you need are done, all that sort of stuff. The whole point of this platform is to make it so that if you were a software developer and you don't want to have to care about infrastructure, you don't have to. If you want to deploy a really simple app, you just deploy a really simple service descriptor and magic happens. Right? That's what we want. The whole idea is to make the platform be just magic. You know, yeah. And I mean, this is kind of this sort of thing. Like, this is what you get when you work at Google, right? Like, there's magic, and you don't have to care about the magic. If you want to care about the magic, knock yourself out, but you don't have to care about the magic. Yeah, so the service workloads are coming. This is where the platform stuff is coming. I've done some basic investigation into service meshes and stuff. When you're running at the sort of scale that we'll be running at, we're in the magnitude of thousands of microservices that we will need to port across to things. You know, service discovery is a massive problem. You know, constant things are fine things, but because we're so tightly coupled with Kubernetes, you know, the Kubernetes service meshes are probably going to be the way to go. I talk to people a lot about service meshes, and a lot of people are like, I don't understand what you get out of them. The simplest answer that I can give people is it solves your service discovery problem. It pushes the service discovery and configuration into the mesh itself. It's like a really decentralized way of doing it, but the net result is that every app knows how to get to every endpoint of every other app without you needing to do anything. And that's the magic. Happy to talk more about that later too. So, some stuff is not great. Like I said, managing etcd is hard. You know, managing any Raft app means you need to be very careful about consensus and quorum. You know, we've had lots of problems where it took us a long time to come to the realization that for our etcds, we needed to turn on the thing in Terraform for EC2 instances that says, once this instance is provisioned, don't make changes. We'll change the config, but we don't want you to make a change without us doing something. And so practically that means when we roll etcds, it's super manual and it really sucks. But we don't have big outages because someone fucked up something on that Tetrad config. Yeah, the Goliath layer needs work. It's an Ansible setup. It's an Ansible rig that basically just renders huge stacks of kubectl and then kubectl apply-fs them. Right. So, you know, we looked at Helm and stuff, but the Helm v2 is not compatible with our security model because you have to run Tiller inside your cluster. Tiller has to have cluster admin to be able to do that. If you have Tiller running in cluster admin, if anything else gets to Tiller, they now have cluster admin as well. And because we're running in a multi-tenancy kind of mode, even in the internal clusters, we're running in a multi-tenant mode. We have clusters that are used by external customers that are hard multi-tenancy, where tenants shouldn't be able to see each other. You don't want them to interact with each other. You don't want them to be able to know about the other tenants. That is the hardest security problem to solve in Kubernetes at the moment. Lucky us, we gave it to ourselves. But because of that, we're basically doing a whole bunch of security work on those clusters and backporting that to the rest of the clusters, because hell, why not? But yeah, so as I said, security is a challenge. Security across Kubernetes is a big challenge at the moment because it's still such early days. Not many people are doing stuff that requires the level of security that you can turn on in Kubernetes. We have pretty much everything that you can have turned on, and we find problems all the time. Pretty much anything that you find online that's like, hey, run this on Kubernetes, won't work on our clusters, because it'll be like, you know, I want to create a privileged pod, or I want to do this, or something like that, and we have specifically locked off large portions of access unless you do special things. So yeah, if you are doing stuff like, that's one of the things I would say. Think carefully about the security. There's a lot to understand about security. If you are running single tenant clusters, like where it's okay if everybody sees everybody else, this will be much less of a problem for you. And I would say do that until you have a reason not to. So overall takeaways. Like I said, do as I say, not as I do. Don't build your own platform unless you have to. If the managed platforms, if you haven't started using Kubernetes yet, I will put $20 on the fact that the managed platforms will be good enough for you right now. Even if they're not good enough for you right now, you should use one of the tools that's available to build your clusters. You know, use managed platforms until you can't, then use a tool to do it, because the tools right now have a whole bunch of the security stuff and all of the other stuff you should care about baked into them as defaults. Like I said before, immutable infrastructure is your friend. Anybody who has been doing ops for a long time knows the suckiest things come from having someone have logged into a machine 10 years ago and done some special super smart thing, and now you need to figure out what the hell they did. They haven't documented it. Nobody knows what's going on. Oh, we can't turn that machine off because when we do, everything breaks. Like, we've all been there. It sucks. The way to do it, yeah, the immutable infrastructure means you can't. Like, you know, even if I wanted to make changes, I can't. Like, it makes you think carefully about what you're doing. Manage your dependencies careful. I've talked about this enough. Use layers. Build yourself a layer cake. Keep the demarcation points between layers easy to understand and easy to use. The API server is a natural layer boundary. Think like whatever you do to get an API server, that's one set of things, and then the things that you pour into the API server are a separate set of things. There's a really clean demarcation point there. Try not to violate that too much. And the last one is get involved. Kubernetes the community is super welcoming, like ridiculously so, even though there's like 35,000 people in the Slack or something absolutely bananas. But yeah, like, I mean, I'm in 8, 9 SIGs at the last count or something like that. It means that I spend a lot of my day paging through Slack, reading about what's going on in all of those SIGs, but all of the ones where I need to keep up with what's going on. But, you know, it sucks for us in Australia. You can't just casually dial into the SIG meetings like you would in the US because they're on at 4 o'clock or 1 o'clock in the morning, our time. But sometimes it really is worth your time to do that. So, in more detail, why not build your own? Like I said, manage Kubernetes is pretty great. It's already sort of covers 80 to 90% of the use cases, and that's getting better every day. EKS is GA now. Basically, all 3 big cloud providers have their own managed provider. Managed service, and they're all pretty good. You really don't want to run etcd. Running your own etcd is the level of black magic that it was to run your own database 30 years ago. Like, it is real black magic. Like, there's a whole bunch of stuff that you just don't know until it completely screws you. And then you'll have a sad, sad day. Yeah, if you must build stuff that's not a managed Q cluster, use the tools. COPS, Kubercorn, KubeADM, they're all usable now. And all of those work across all 3 clouds or on bare metal. But with the caveat that if you really want to understand what these tools are doing, do Kubernetes the hard way. It is your friend. Thanks everyone. Happy